A colossal asteroid, ominously dubbed a city killer, is hurtling toward Earth with breathtaking speed. As it races through the void, this celestial giant looms as a potential harbinger of disaster, casting a shadow of uncertainty over the planet. Its looming trajectory could spell catastrophe. Cities might vanish from maps, landscapes transformed in an instant by its incredible force. But is this truly our fate? Or is there still time to rewrite the ending of this cosmic thriller? Are we on the brink of a momentous U-turn in the case of the asteroid Apophis? NASA experts had initially calculated that the 350-meter-wide rock would narrowly miss Earth in April 2029. However, a new study by Canadian astronomer Paul Wiegert suggests that the probability of an impact is higher than previously thought. The reason? Even a collision with a small object could nudge Apophis off its current trajectory, putting Earth directly in the path of this cosmic bullet. To make matters worse, we can't even accurately estimate the risk of collision at the moment. Apophis is currently near the Sun and won't return to our field of vision for another 2 years, leaving us in a state of uncertainty. For many, Friday the 13th is a date shrouded in superstition and dread. Fortunately, experts have already given the all-clear for Friday, April 13th, 2029. On this day, Apophis will not crash into Earth, but will instead pass close to our planet. Close, in astronomical terms, meaning a distance of 31,700 kilometers. Yet, this reassurance wasn't always the case. When Apophis was first discovered in 2004, there was genuine concern that it might collide with Earth. Named after the ancient Egyptian god of chaos and destruction, Apophis quickly earned the ominous nickname Killer Asteroid in the media. At one point, the impact probability was estimated at 1 in 37, or 2.7%, the highest ever recorded for an asteroid of its size on the Torino Impact Hazard Scale. A colossal asteroid, the size of a football field and ominously dubbed a city killer, is hurtling towards Earth with breathtaking speed. As it races through the void, this celestial giant looms as a potential harbinger of disaster, casting a shadow of uncertainty over the planet. Its looming trajectory could spell catastrophe. Cities might vanish from maps, landscapes transformed in an instant by its incredible force. But as more precise observations of its trajectory were made, initial fears were alleviated. It is now considered highly unlikely that Apophis will pose a threat in 2029, unless, of course, something unforeseen happens in the coming months or years that undermines all our mathematical predictions. Specifically, an event that decisively changes Apophis's trajectory and turns it back into a cosmic hazard. In fact, Apophis' path has already shifted. 5 years ago, astronomers determined that the Sun's radiation pressure alters the asteroid's course by about 170 meters annually. While this isn't enough to direct Apophis toward Earth, a small nudge from an object as small as 60 centimeters could be enough to do so. If Apophis were to hit Earth, it wouldn't conjure up an apocalyptic scenario like the asteroid that wiped out the dinosaurs 66 million years ago. However, the consequences would still be catastrophic. Experts estimate that the impact crater alone would span several kilometers in diameter, and the force of the collision could devastate an area the size of Central Europe. If Apophis were to crash into the sea near a coastline, the resulting mega tsunamis would be equally devastating. But how likely is this scenario? Paul Wiegert has asked himself this very question. Using a model simulation, the Canadian astronomer from the University of Western Ontario investigated what would need to happen for Apophis to set a course for Earth. Wiegert had to rely on theoretical calculations because Apophis has been invisible to us since 2021 and will remain so until 2027 as it moves close to the Sun. During this period, even the most powerful telescopes cannot observe it. Near-Earth objects, NEOs, are asteroids or comets nudged into our neighborhood of space by the gravitational attraction of nearby planets. They are chunks of rock, metal, or ice left over from the formation of the solar system some 4.6 billion years ago. Most are too small to worry about, but an impact from larger NEOs could cause considerable localized damage, such as the meteor that struck the Chelyabinsk region of Russia in 2013. It shattered windows and caused hundreds of injuries over a wide area. Destruction from the largest of these objects, such as the asteroid that likely caused the extinction of the dinosaurs about 65 million years ago, could wipe out humans. Optical telescopes are the best bet for spotting NEOs, but radio telescopes are the surest way to determine distance, according to Anne Verkey, a research fellow at the University of Helsinki, who has tracked asteroids using radar. And that's kind of the third dimension that's really important, she says. Radio telescopes, which use a giant dish to collect radio waves emitted from celestial objects, can also be used to bounce a radar off NEOs to determine their size, Fools says. Unfortunately, 2024 YR4 is already too far away for that. But there are other ways, he says. Wigert's simulation focused on how large an object would need to be to deflect Apophis to a threatening degree during its invisible years. Previous studies had concluded that the asteroid's trajectory would need to shift laterally by about 200 kilometers to enter a keyhole, a small zone near Earth where our planet's gravitational pull could deflect Apophis in 2029, causing it to impact Earth on its next approach in 2036. Wiegert found that a collision with a celestial body just 60 centimeters in size would be enough to guide Apophis through this keyhole. Such a collision would change the asteroid's speed by around 31 thousandths of a meter per second, setting in motion the required 200-kilometer shift in orbit. A 2023 NASA report says the very biggest asteroids like the one that killed the dinosaurs are few and far between, and the space agency thinks all of them have been identified and tracked. Another 95% of those a size smaller, which NASA describes as able to cause global devastation and the possible collapse of civilization, have been discovered. After that, the objects become less lethal, but fewer of them are known. Asteroid 2024 YR4 is thought to be between 40 meters and 90 meters in diameter, 130 feet to about 300 feet, which puts it between two of NASA's lower classifications, 50 meters, 165 feet, which could cause local devastation, of which only an estimated 7% are known, and 140 meters, 460 feet, with 40% unknown and the potential to be deadly over metro areas and states with likely mass casualties. The ESA plans to launch a spacecraft of its own called Ramses. The Ramses spacecraft, which must be ready to launch a year ahead of time, will meet Apophis before it passes by Earth and accompany it on its way out of our orbit. During that time, the mission will observe how the surface of the asteroid changes from being in such close proximity to Earth, the agency said in July. For an impact in April 2029, however, a significantly greater momentum would be required. Apophis speed would need to change by about 0.05 of a meter per second, which would require a collision with an object about 3.4 meters in size. Even then, the collision would need to occur at a specific time and in the right direction. Statistically, about 140 objects of 60 centimeters hit Earth every year, while only one object of 3.4 meters does so annually. Applying this to Apophis's much smaller cross-section, Wiegert estimates the probability of Apophis being pushed into the keyhole by a collision at just 1 in a million. The risk of an impact in April 2029 is even lower, at 1 in 100 million. Given that only 5% of collisions with a 3.4-meter object would provide the necessary momentum in the decisive direction, the probability of this scenario is less than 1 in 2 billion. In other words, the risk of an impact can confidently be described as very low. Yet, very low does not equal zero, and that's the crux of the matter. As things stand, we cannot completely rule out the possibility that Apophis will smash into Earth. If it does, all our mathematical predictions will be rendered useless. What could be of great use to us, however, is a DART mission 2.0. In the fall of 2022, NASA demonstrated how the trajectory of an asteroid could be successfully manipulated by a targeted probe impact. Such a mission could be crucial if Apophis were to become a real threat. The ongoing scientific preparation is not just about observation. In September 2022, NASA demonstrated that it was possible to nudge an incoming asteroid out of harm's way by slamming a spacecraft into it as part of its Double Asteroid Redirection Test, or DART. Launched in November 2021, DART traveled for more than 10 months before crashing into Dimorphos at roughly 14,000 miles per hour. Though the tiny asteroid posed no threat to Earth, NASA had set out to test a method of redirecting threatening objects hurtling toward Earth. Now, a craft from the European Space Agency is on the way to get an up-close look at the asteroid's remnants. Hera launched October 7 from Cape Canaveral Space Force Station in Florida on a 2-year journey to Dimorphos, which is a tiny moonlet asteroid orbiting the larger 2,560-foot space rock Didymos. The spacecraft is expected to enter the Didymos Binary Systems orbit in October 2026, when it will determine just how effective NASA's test was, according to the agency. Officials hope that by analyzing the results of NASA's experiment, space agencies will be better positioned to repeat the maneuver. Public awareness is also crucial to understanding the cosmic threat Earth could one day face. In that spirit, the ESA recently announced its support of the United Nations designation of 2029 as the International Year of Asteroid Awareness and Planetary Defense. The designation, intentionally timed for the year of Apophis' close approach, is meant to foster international cooperation on planetary defense strategies, while educating the public on near-Earth asteroids, the ESA said. At the same time, Apophis is more than just a potential hazard. It also represents a rare scientific opportunity. An asteroid the size of Apophis passes by Earth only once every 100 years on average. Experts are eager to study its interactions with Earth's gravitational field and the potential changes in its physical and dynamic state caused by tidal forces. These interactions could cause dust avalanches or even alter the asteroid's rotation, providing valuable insights into the structure and composition of such celestial bodies. To capitalize on this opportunity, experts are currently discussing 2 mission concepts, Ramses and Satis. The goal of these missions is not only to visit Apophis up close, but also to accompany it for an extended period during its close flyby of Earth. The European Space Agency's ESA Ramses mission has the advantage of building on components already developed and tested for the Hera probe. Hera, launched on October 7, 2024, is currently on its way to the binary asteroid Didymos and its moonlet Dimorphos to analyze the effects of NASA's DART mission. On the other hand, the SATUS mission, based on the low-cost CubeSat concept, would likely be more economical. CubeSats have become an industry standard for small satellites, though some components would require more complex development compared to Ramses. Regardless of which mission is chosen, NASA's OSIRIS-APEX probe will also head to Apophis, but not until August 2029, several months after its close approach to Earth. OSIRIS-APEX, originally launched as OSIRIS-REx on September 8, 2016, previously visited the asteroid Bennu, successfully collecting a sample that was returned to Earth in September 2023. While the risk of an Apophis impact is minimal, it is not zero. As such, it is crucial that we continue to monitor this asteroid closely, especially after it returns to our field of vision in February 2027. At the same time, we must not overlook the scientific opportunities that Apophis presents. By studying this asteroid, we can gain invaluable knowledge that will help us prepare for future encounters with potentially hazardous objects. Whether through missions like Ramses and Satis, or continued observation. Apophis reminds us of the delicate balance between cosmic threats and the quest for understanding our universe.